Our next operation involves locating the center of our block, drilling a 1/2 inch hole, and then with an edge finder going into each 4 corners of the block, drilling and reaming a hole for a 1/4 inch dowel pin. When we're working along that line, I think it's a good idea to use a magic marker or a Sharpie felt pen and write some dimensions on our block so we're not constantly having to go back to the calculator or figure them mentally. Another good idea is to make a little diagram, and you'll have a print showing you the dimensions on this specific block. Write those dimensions down on a 3x5 card, set it next to the mill for a handy reference. It keeps you from running back and forth to the bench to check dimensions. So we're going to take our felt pen, we're going to mark some locations here. From each corner, we're going to come in 625 thousandths. That's the location of a hole that we're going to drill and ream to 1/4 inch. Those holes will be a depth of a 1/2 inch. Next, we're going to locate the center of our block. We're going to drill a hole a 1/2 inch clear through the block. Then we're going to come back and pick that up a little bit later. So with those markers on our block, let's install our drill chuck and the edge finder and get to work. Okay, don't forget in this operation to add your 100 thousandths for the offset in the edge finder. You'll notice that I've written the 1/2 dimensions down on our part in those 2 directions. Again, we have a simple reference to work from. Let's get started. Okay, very gently bring the edge finder up to contact the work until it offsets. We'll retract it just a little bit. So our x-axis, 2 inches and 50 thou. Okay, we can lock our table in at that point. Now we're going to work off of the y-axis. One inch 412.5. Okay, we've now located the center of our block. It's time to drill our 1/2 inch hole. Remember to be aware of the position of the quill handle when we get ready to drill. We want to be pulling down, not pushing away in case it slips. Always center drill our hole. Come in with our pilot drill. Take the time to clear the chip now. Simply don't bury the drill in the part. You want a nice straight hole. Okay, we're now ready for our 1/2 inch drill. We're going to slow the speed down just a little bit. I'm going to go to 660. Okay, never grab those chips while the drill's turning. Always stop, remove the drill from the chuck, then remove those scary chips. We don't want to be calling you stub at the annual picnic. All right, we've located our hole in the center. Now it's time to put our edge finder back in, but before we do that, you can see that we've raised a burr around the top of our hole. So let's grab our countersink and we'll go ahead and just break the edge off. Okay, there we go. Got a nice burr-free hole at that stage of the game. Okay, now once you've been machining on a part, if you're going to be using the edge finder again, take your paper towel, wipe all the chips and debris off of our block so they don't interfere with our edge finder reading. Remember, 625 thousandths from each side of the part. We'll start in this corner first. All right, for those of you that don't have a digital readout, it's real good practice now. Loosen, lock the table down once our edge finders come in contact. Loosen the lock nut. We're going to zero out our dial and advance 625 thousandths plus the 100 for the edge finder. We're going to work over to the other side of our part. And repeat the process. Forget, we want an accurate zero when we establish our edge. Okay, we'll go back to our center drill. Remember, when we're going to ream with a 1/4 inch hole, we want to drill as close as possible, leaving a few thousandths for the reamer to clean up the hole and bring it to size. We're going to be reaming with a 1/4 inch reamer. We've chosen the letter C drill out of our drill index, which measures 242 thousandths. That'll leave us roughly 8 thousandths for the reaming process. Now at this stage of the game, we're going to drill the hole a 1/2 inch deep. We're going to leave the chuck and table settings the same, so we want to bottom the drill out in our Albrecht chuck. Adjust our quill travel. When we start cutting full diameter on the drill, you'll notice the drill's got a cone shaped on the end of it, 118-degree split point. As soon as we get up to the full diameter of the edge, that's when the depth of our hole starts. Okay? So watch closely now. We're going to come in contact with our center drilled hole right at the point that we're drilling full diameter. Go ahead and shut the machine off. Bring our drill down. And we can raise our quill stop. At this point, okay? You can either use a 1/2 inch spacer block, a 1/2 inch dowel pin, works really fine. Simply loosen our lock ring. Roll that down. We can even use the 1/2 inch shank on a mill cutter if we want to use that as a spacer. Simply going to insert it between our stop. Screw it up till it contacts. Bring our lock ring up. Presto changeo, we've now set it for a 1/2 inch within just a few thousandths. Another neat little tip and trick that you can use. They also make gauge blocks for that in your spare time. If you're drilling a lot of holes to specific depths, go ahead and machine up little aluminum blocks or steel blocks that you can use as spacers between your quill stop. All right, so let's retract the drill now. Go ahead and drill our part to final depth. Make sure and clear the chips from time to time. There we are, we're up against our stop. Okay, we're now going to insert our reamer. Remember, when we ream a hole, we need to slow down the RPM. There's no way that we can ream this hole at the same speed that we drilled it. We'll take a little bit of thick sulfur cutting oil, fill our hole up, shift our machine into back gear. We're now ready to ream our hole. Make sure and clear the chips. If they start to get a buildup, we're only removing 0.08. Bring the reamer down until it bottoms in the hole. Treat your reamers as you would the rest of your tools, very, very gently. Okay, we now have a reamed hole that's a 1/2 inch deep. We're now going to move on to our next hole. Keep in mind, we've already figured our 625 dimension from this side of the tool. So now, if we want to get fancy, we can get out our calculator, measure the width of the block, subtract 625 away from it, and advance in the y-axis over to the next hole. Or if we feel we need a little more practice with the edge finder, slip the edge finder in, come over off of this face, contact, come in 625 thousandths for the location. The reason we're having you to do this is to get the feel for using the edge finder. It's a very, very important tool. It's a very sensitive tool. We need to exercise a little bit of finesse when using the edge finder for precise location of our holes. I'll go ahead and finish up the holes. We've shown you how to do the first one, and I'll join you in just a minute. All right, I've finished up our 4th hole. Now let's go ahead and put a chamfer on the tops of those holes because they're just razor sharp right now, and this will also allow us to drive the dowel pin in a little bit easier if it's got kind of a chamfer or guide. Remember the little tip we showed you earlier about using the countersink, bringing it down in contact with the hole, setting our quill stop, and then backing it off so we can cut uniform depths in all 4 holes. Now, for those of you that have done the math, this is going to work out really well. We should have been keeping track of the number of thousandths that we needed to move from hole to hole to hole on the X and Y axis. Those should be written down on a little notepad somewhere. If they're not, grab the calculator, a sharp pencil, and make those necessary calculations so we can just adjust the table around to 4 different positions while we've made this adjustment in our countersink without having to use the edge finder again. Okay, we've got a 20 thousandths adjustment. Let's go ahead and chamfer our holes now. That's what the first one looks like. Now we're going to move to the second one. With all the handwork that you're doing, the next time the digital salesman enters the shop, you're probably going to buy one of those digital readouts. For this type of work, it's a real lifesaver. All right, with our center hole located, our 4 holes for the dowel pins drilled, reamed, and chamfered, it's now time to clean the block off, turn it on edge, and let's practice some more drilling and tapping. Alright, our next operation involves drilling and tapping 3 holes. The tools you're going to need to perform these operations are a center drill, a number 7 drill, a countersink, a 1/4-20 tap, and the edge finder. We're going to locate the holes 1 inch in, centered in the width of our block. So if you don't have those measurements committed to memory, grab the dial calipers, divide them by 2. Don't forget to add the 100,000ths for the edge finder. And now let's begin. Okay, remember we showed you different methods of tapping a hole in the mill. You can use a tap guide, which we've inserted in the chuck now, or if you don't have a tap guide, simply insert the tap in the chuck, turn the machine on and off, and as the tap starts to slow down, feed it by hand from the quill into the workpiece. Remember to keep it rotating slowly. We don't want to break the tap off. We don't want to have it bottoming in the hole and then proceed to finish the hole by hand, either by turning the chuck or by removing it and inserting a tap handle. We'll use a little bit of WD-40. We'll show you both methods just as a refresher course. Very gently rotate the tap 3 or 4 revolutions till you feel the tap start to get tight. Reverse directions, break the chip hold. Continue. 1/4-20 taps, pretty tough, but you can break them if you get a little heavy-handed. Take your time. Remember, we want to feel each operation that we do as a machinist. Okay, there's one done. Let's go ahead and advance over to the next hole. Okay, we're going to do this one with the tap guide as well, and then we'll finish up on the last one using the drill chuck as the driver for the tap. Little tap handle I'm using is made by the folks at Starrett. They're kind of expensive, but believe me, they are the finest little tap handle going. It's just a neat thing to have in your toolbox. I get a lot of pride and satisfaction out of owning and looking at well-designed tools, and I'm sure you do the same. Nothing's worse than a piece of imported junk that was simply cast and never finished off. They had no pride in the finished product. Something you simply hide in the toolbox rather than show it to your friends when they come over for a visit. Okay, now let's remove the tap guide. We're going to insert the tap in the chuck. We're going to advance down to the next hole. Clear the chips, give it a shot of WD-40, and watch closely now. We're going to turn the machine on, let it slow down a little bit, and then advance the tap into the hole. You can manually turn the chuck now, backing it out, clearing the chip as we go. The chuck's holding our tap in perfect alignment and concentricity with the hole. When you feel the tap start to get tight, it usually means we're bottomed out against the hole. Simply exert a tiny amount of pressure upward on the quill arm and remove the tap. And there we have it, another tapped 1/4-20 hole. Now let's go ahead and install our countersink and go back across those holes and give a countersink to each of those threads so the bolt or screw starts smoothly. Okay, remember, we'll clear our chip out of the way. We'll bring our countersink down in contact with the hole. We're going to use our quill stop. And we're going to back it out 30 thousandths this time. We're going to go across and chamfer all of those holes. Okay, now our block's starting to take shape. We've got 3 properly tapped holes. We've used the countersink. They should all be of uniform depth and diameter. But before we move on to the next phase, I have a couple of questions for you. How many of you, when you had the center drill in, after center drilling the first hole, automatically went to the second and then the third hole, inserted our drill, reverse directions, drilling all 3 holes simultaneously, and then started the tapping operation? If you did, take your hat off. You're starting to catch on to the idea of a production method of making parts. This drilling application, there was no reason why we had to drill, center drill, and tap each hole one at a time. While we've got the tool in, the holes were spaced close enough that we could simply advance the table 5 revolutions. Remember, they're on 1-inch centers. Center drill the next hole, 5 more revolutions, center drill that hole, and then take up the backlash. Reverse the procedure, drilling our hole to depth, come back across and tap them. That's the correct way to do it.